Hey everybody, how you doing? Dr. Heldman here. This is another movie in the series that I'm doing on Linux cluster computing. And what I want to do is walk you through how to install a better IDE than just like the Nano or something like that, so that you can learn how to write code inside the IDE that you'll use in your Linux cluster node C programs, and then it'll be useful for Python as well. We are going to install Microsoft Visual Studio Code today, and I hope you enjoy it, and you can use this product to develop the rest of your C code for our little MPI labs and also for other things we might do. So let's get started. Now, the reason I want to use what is called an Integrated Development Environment, an IDE, this is a piece of software that you download and install, and it allows you to write code inside the IDE and then compile it if you need to, or you could go ahead and just use it as a word formatting tool for you so that you can make sense of the code, get it all highlighted correctly. One of the uses of an IDE that's really good is it color codes all of the different things you're trying to do in the code, and it also will tell you when, especially in the case of C and C++, when you're missing a curly brace or a semicolon and things like that. The one that I think is the best, Microsoft Visual Studio, has been around a long time. It's a very mature product. It's an expensive product, so if you were to go download Visual Studio natively, it would be expensive for you to purchase that product. You can download a trial version of it. This is likely the IDE that quite a few developers around the world are using. It's a very good one. But then a few years ago, Microsoft released an open source version called VSCode, Visual Studio Code, and it's free for the download. And the thing that it has going for it is that it can run on any operating system like Linux, Windows, or Mac. So that's what we're going to use, and I want to show you why we're going to use it, because it's really handy when you're writing your code to get you away from things like Nano, things, text editors like that don't offer as much variety in terms of how you're trying to visualize this code. So that's what we're going to do. So the first thing I want to do is I want to go out to the web. I've already brought the page up here. I'll click it here. And of course, this is Firefox. The URL to get Visual Studio Code is https://code.visualstudio.com, and that's where I'm at now. You need to differentiate between the term Visual Studio, which is a formal development environment that's been around for decades, and it's in use by a bunch of coders. It's very robust, very good. And this particular release, which is for the open source community, so that's good. And you can see here that I've already selected Linux as my preferred download. You can see that I can download a Debian or an RPM. So I downloaded the Debian. I already have it. And so I just wanted to show you where the URL's at and how you get this. Make sure that you're downloading the Debian version of this. So I've got it downloaded. It comes down into your downloads folder. So I've changed into downloads. Let me show you what I did. I went to CD space downloads, and you do a space here because downloads, oops, it's downloads plural. Downloads is local to you in your home drive, so you don't need the slash there. It's telling you already that you're in the home folder, and the slash is saying that I'm in the downloads folder now, or directory. These are called directories. If I do an ls here, you can see in red there that this code 1.98 blah 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 amd64.deb. You could rename that if you did not want to type all that in. There's really no need to type it in though. So the next thing we want to do is we want to get this installed. So it's just like any other software here. I'm going to just go ahead and copy this, highlight this URL, this file, and I'm going to right click and select copy. Then it's just like any other installation that you do. It's sudo apt install, and in this case what we're going to do is we're going to point to the path to the Debian package. So it's // because we're in the same folder as the Debian package itself, and then I will right-click and paste that in there, and now I'm ready to go. That's how you go about installing. Let me widen this out a little bit just so you can see what it all looks like. There we go. So I hit the enter key, and I did not put a TAC-Y in there. I could have put a TAC-Y in. This thing will take a minute to install. There's quite a bit of code going on in an IDE. So I'm going to pause the movie and come back to it in just a minute to show you how we go ahead and launch it and begin using it. Okay, you're going to get prompted. This is called a TUI, and you're going to get prompted. It says here, do I want to add the Microsoft app repository for Visual Studio Code? I think you should. And so I'm going to hit enter. All right, so I have cleared the screen, and now what I want to do is I want to point to this application on the desktop. Let me show you first of all where it lands. We're going to park that on the desktop in just a minute, but let me show you where it lands normally. So under applications, now this is in the XFCE desktop, it shows up under development right here, and there's Visual Studio Code, and it'll launch that way just fine. That's what it looks like. I'm going to close this, and what I want to do now is I want to copy it to my desktop if you wanted to, just to make it easier. Let me show you where it lives. So if we cd to /user share applications and then do an ls for code star, you'll see that there's two of them. There's this code URL handler and then code.desktop, which is in green. That's the thing that we can move to our desktop or copy to our desktop, so we can see this URL here, this application shortcut here. And here's the way that you do that. I'm going to go home. I want to make sure that I realize that it's called code.desktop. So I hit enter and then clear the screen. I'm going to copy /user share applications code.desktop to // that's my home folder, and then cap desktop, and that will copy it over to your desktop so it's available that way as well. Now you'll notice that it did not give me an error when I tried to launch it here like so. It blows up just fine, everything's good, but if I try to run it from the desktop, it's going to prompt me. You'll have to maybe think about ways to fix that. It says that I need to mark it as executable. I've actually done that. And it says, if you do not trust this program, click cancel. I'm going to launch it anyway. So that's the difference between it living on the desktop and living on your, living in the pull-down menu here. Okay, so now what you're looking at is the Visual Studio Code welcome screen. This is popular in Visual Studio, and it's popular here in VSCode. Keep in mind that Visual Studio is an app that you have to buy. It's relatively expensive. Companies routinely buy licenses for it. VSCode is an open source version that you can use. It's especially good for C, C++, and Python code, in addition to other types of code. Now in this case, what I'd like to do is I want to open a file, but before I do that, let me show you how you can change the screen colors. So here's your gear wheel right here under Manage, and you go to Themes, Color Theme, and we could pick a different color theme if we wanted to, like Solarized Light. It'll show us what that looks like. That's a little bit too weird for me, so I'll go back to Themes and pick another one. And I'm just looking for something that is a little bit lighter. I'm going to go with Visual Studio Light here. That looks fine to me. Now the next thing that I want to do is I want to open up a piece of code that we've already written using MPI. So I'm going to open a file. I love this feature because it brings up the File Explorer for Linux for me. So rather than opening it up using the file system over here, what I can do is just use VS Code to open it up. And I'm going to take a look at Ping-Pong because we want to see what the heck that does. Now, one of the reasons that you really want to work with an IDE like a Visual Studio is because it's going to highlight things in colors. It's going to show you different colors so that you can tell what's what. It gives you line numbers, which I love. It gives you squiggly lines here, like it doesn't understand where MPI.h is at, And I'll chase that down in a later video and show you how to get rid of that. But for now, all I'm doing is using it as a code editor, and then I will compile and run the code from the command line. But ideally, what would be great is if we could get it to compile and run the program right inside VS Code, but we'll do that in a bit. The run button is over here. It's debug, or if I click the drop down, you can run it. So that's a good way to just run the file right away. So I've got this code in here. It's giving me line numbers. You can see in blue that this is some sort of a C statement. That's an include directive. It doesn't know what MPI.h is. It does know what standardIO.h is, though. And then we come down and we have the code here. Now, when you highlight a curly brace like this, it draws a nice rectangle all around it. The beautiful part about that is it shows you the match down here, the mate to that curly brace. The reason I like that is because when you're here inside some code, we've got an if, we've got a couple of ifs going on here, we've got a for loop going on. It could be that you forget to put in a semicolon, in which case you want to find out where it's at. So we say this like that, and it'll show me where the match is at, right there, like that. So that's pretty cool. Here's my other one. Let me see. Yep, that matches. And all you have to do is click to the left of the curly here. Click to the left. It shows you its match. Click to the left. It shows you its match. That's worth the price of admission just to get into Visual Studio Code itself. Also, if you happen to leave out like a semicolon right here, at compile time, what it will do is it will prompt you. Now remember, we are not yet able to compile MPI code in VS Code. We'll work on that and get that running later, but for now all I'm doing is using it as a text editor. Now let's take a look at what we've got, because I told you that I wanted to run through some of the more difficult parts of the code here. So let's first of all take a look at line 15. We're declaring a variable called partner rank. You see it's a little bit different color. It's going to set world rank, it's going to add 1 to it, and then it's going to do the modulus operator with the world size. And it's going to come up with a number. Now what the heck is it doing? Let me bring up the document that I created, and I'm going to go ahead and copy this little bit of this Word document. I'll just copy it as text into the video notes so that you have that and you can go take a look at that. So world rank is the rank of the current process. So you remember that we have 3 nodes running. If you had 1,000 nodes running, they'd all have a rank. And the idea here is that master node is 0, compute node 1 is 1, compute node 2 is 2. So this is the rank currently. The world size, on the other hand, is the total number of processes that we want to use. And we said number of processes, TAC-MP, is going to be 6. So that's my world size. Now world rank plus 1 increments the current rank by 1 to find the next process in the ring. Now this is ping-pong, so what we're trying to do is get it to go back and forth, just show 1 or 0. And so the reason that we call it a ring is because we're just round-robining through this thing to make it do what we need it to do. And finally, world rank plus 1 modulus world size ensures that the rank wraps to 0 when it exceeds the total number of processes, creating a circular ring topology. That's a word that's typically used in networking, but in this case, what we're doing is we're wanting it to ring around through all of the nodes to be able to answer questions for us. Here's how it works. So to give you an example, we have a world size of 6. We know that we have set TAC-MP to 6. World rank is 0 currently. And so we're going to say 0 plus 1 is 1. Modulus 6 equals 1. So the partner rank is 1. We're declaring partner rank right here. Partner rank is going to be this. Then if we have world rank 1, we do 1 plus 1 is 2. 2 mod 6 is it's the remainder of 2 divided into 6. And so we get a 2, and then we get a 3, and we get a 4. That's how it's working. So the modulus, you can prove to yourself how it works by simply bringing up the Windows calculator or the Mac calculator. Let's do that. You can practice yourself with the scientific calculator here, and the thing that you need to know is it's going to be one number divided by the other, but we're going to return the remainder. So here in process 0, world rank is 0, 0 plus 1 is 1, mod 6 is 1 because there was a remainder of 1 here. And you can prove this to yourself by just bringing up the Windows scientific calculator here, go 1 mod 6 and hit enter, and sure enough you get 1. Here's 1 plus 1, so that's 2 mod 6, mod 6, and we get 2 and so forth. Now the idea here is that it's going to wrap, so we get 1, 2, 3, 4, 5, and then it wraps back to 0, and that's the point with that particular piece of code. So here, that's the calculation that we're doing right here. We're doing partner rank. And if I click partner rank, one of the advantages of the IDE is it shows you where these particular variables are referenced inside the code. So we've got that. Now we come up and we say, well, if world rank is equal to 1, is it true that it's 1 modulus world size? So we're finding out if that is true. Let's go look at what the code says about this. I didn't quite finish the notes here. The purpose is that this particular one where we're doing the world rank calculation, the partner rank here, is that it creates a ring topology. 0 sends process 1, 1 sends to process 2, 5 sends to process 0. So we've got this ring operation going on here. That's why they're calling it a ring. Here's the next one. If world rank equal I percent world size. So what is that doing? So I is a loop counter. This is very common in C code. And the way you set it up, in fact, you can have nested loops. You could have an I doing a thing for certain iterations, but then you could jump into another loop and do something in this loop for a certain number of iterations while still at the ith level of the loop. So I is 0, for example. This thing comes in here and runs. It's called J. So what C and C++ programmers do, if we're going to do what's called a nested loop, we'll declare an I, which stands for the outer loop, and a J, which stands for the inner loop. We don't have that in this case, but that's the concept. We're going to loop from 0 to 9 for 10 total iterations. I mod world size computes the remainder of I divided by the world size, and the idea is still that we're going to cycle through ranks 0 to world size minus 1. And it's saying here the condition world rank equal I, is it true that mod world size determines which process gets to send a message in each iteration. So we're talking about now we're going to pass this. That's the idea of what we mean by message passing interface. We're passing and we're saying, hey, it's your turn to do this, your turn to do this, your turn to do this. And then when it does that, it sends it back. Okay, I've done this, I've done this, I've done this. Now they give you some good examples here. If I is 0, which is what it currently starts out at, then it's going to be 0 mod 6, which gets 0. So process 0 is the first one to send something. Then process 1, process 2, 3, 4, 5. It gets to process 6 and starts over. And when it gets to process 9 here, it's at process 3 gets to send. So the concept here is pretty cool. As long as you understand how a loop works, this for loop, and how these modulus operators are working. Very clever stuff. The modulus is used quite often in code, especially in cybersecurity code, for encryption algorithms and things like that. What is this doing? Well, it assures that each process takes turns sending a message in a round-robin fashion across the 10 iterations. Since there are 6 processes and 10 iterations, some processes, ranks 0 through 3, will send twice, while other ranks, like 4 and 5, will send once. Now, let's go back and look at this code, because there's a send here. This is a function. This is an MPI function. There's one called MPI send. There's one called MPI receive. There's one called MPI barrier. We've talked about finalize. It just cleans things up. And then we get the comm size and comm rank, communication size and rank. But we need to know what this send and receive does. So let me bring up the Word document so you can see what's happening here. The MPI send function is used to send a message from one process to another. And so let's break down the arguments here. So it's a huge honking thing. Let's take a look here. So it's MPI send. Our first argument is ping-pong count. Our second argument is 1. Our third argument is MPI int. Then we have our partner rank, which we calculated. We have a 0, and then we have MPI com world. And we know about MPI com world, so we can kind of put that together. Now, what's it doing? So let's look. Ping-pong count is the address of the data to send. So this is a pointer to the ping-pong count variable. And what it's saying is this is the address. We're dereferencing this. We're not going into ping-pong count and getting the data. We're getting the address of the data. We are dereferencing it. Ping-pong count is an integer that gets incremented each time a process sends data across. So we're going to increment this. So the data is going to get updated, but the address of the data is going to stay the same. That's the need for incrementing using a pointer to point to that data. The ampersand operator ensures that we are passing the memory address of a variable, memory address, that's the key factor, as MPI send expects a pointer to the data. Now this is why C and C++ can be very, very confusing, because when beginners start out with the C language and C++, these pointers can be quite confusing. But what we're doing basically is we're just saying, here's the data. The computer knows about the data by its address. It's going to be a hexadecimal address that's pointing out to the memory location where the data is at. We know it by a name, and so what we're doing here in this thing is we're saying, hey, go to the memory location of this data right here, and then grab it, grab that information. That's what's happening here. The reason for that is because the MPI send function expects a pointer, so we have to supply it that way. Now, the number 1 here, let's go take a look at that. The number 1 up here, right there, is the number of elements that we're going to send. We're going to send 1 integer. We have to remember that ping-pong count is a single int. Then it says, oh, we're going to call MPI int. Now, these are all parameters or arguments that we're popping into MPI send in order to do its work. So what is this MPI int thing here? This specifies the data type of the elements that are being sent. Now this clears things up because we're saying, oh, well, we're going to use integer data when we're working with this. Now it could be another data type, but in this case, ping-pong int is an integer. And so ping-pong count is an integer, so we're expecting this to have send MPI an int. We've already calculated partner rank. We know how to do that. We did that up above. And then we've got this number 0 here. So partner rank is the destination rank, the rank of the process that's going to receive this message. As computed earlier, blah, blah, blah. And then this is what's called the message tag. The 0 is the message tag. Tags are used to distinguish different types of messages between the same pair of processes. Here we're using a tag for all messages, meaning we're not distinguishing between different message types in this program. You could see, I think, how this could get really, really whiz-bang complicated, you know, if you were having to work through a little bit more difficult type of scenario here. And then here's MPI com world, where we have code that is doing something much more complicated. This is the communicator, which defines the group of processes. So we've got a group of processes that can communicate with each other. So all we're really doing is we're sending the number that is going to do the work for us next. And when it receives that message, it's going to do this printf here. Now we've talked about this already. What we're saying is that %d, process %d, that's world rank, is a decimal. Count d comes from ping-pong count, and partner rank is another decimal that we're passing in. So we're passing in 3 parameters here, 3 variables to this printf statement, and it's going to print something out. However, if world rank equal partner rank, then we're going to pass a 1 in here, a 0. We're going to do an ignore. So we're saying ignore the status just keep going, and we print something out. So that's the concept here, that we're going through this and we're saying, is world rank equal to I mod world size? If that's the case, is it true? We're going to do an MPI send and a printf. If it's not true, we're going to do a receive and a printf. So we're just toggling back and forth between sending and receiving. That's the main part of the code that's happening here. So let's go through the MPI receive segment here. Now MPI receive is a MPI function. It says we're going to pass in the address of Ping-Pong count, because we have to pass in a pointer to the address. We have to pass in the pointer, not the data. We set this to 1. MPI integer, this looks the same as it did before, but we have this new thing, MPI any source, a 0, an MPI com world, and a status ignore. Now on receiving, what we're doing is we're saying, I have sent you instructions to do this, so the thing does it, and then it's like, okay, now I want to send it back. I'm going to send it back using MPI receive. So we've got Ping-Pong count, which we understand. This is the address of the buffer where the received data will be stored. The received integer will be written into Ping-Pong count. Then the 1 means this is the number of elements to receive. We are receiving 1 integer. This matches the number sent by MPI send. Then we have the MPI integer. We talked about that. It's expecting an integer. MPI any source means this, it specifies the rank of the sending process. So what rank is this? So rank 2 gets it. This is going to specify the rank of the sending process. It's a wildcard that allows the process to receive a message from any sender. In this case, the process expects a message from the previous process in the ring, e.g. process 1 expects a message from process 0. By using MPI any source, it makes the code more flexible by not hard coding in the sender's rank. 0 is a message tag. It must first match the tag used in the corresponding MPI send, which in this case is 0, so we just match it. MPI com world is the communicator. It's the same as MPI send. It specifies the group of processes involved in the communication. And then status ignore is interesting. It can be used to get information about the received message, the actual sender's rank, or error codes. You can imagine that in a more complicated cluster node environment, you might have errors that are generated by certain nodes. We have to be able to get that. But we pipe in status ignore because we're telling MPI we don't need this information, so it skips filling in that status structure. When this line executes, the current process waits to receive a message from any sender due to MPI any source with tag 0. So we're matching up the tag and the sender, and we're getting this back after it's done its job. The received integer is stored in Ping-Pong count. They give you an example. And then we've got how the code is working here. So this is really good. Now, I just wanted to do a run through here with you so you could see, first of all, what an IDE looks like, a good quality IDE. If you go out to jetbrains.com, if you're a student or a teacher, you can get quite a few of JetBrains' very, very superb IDEs for free if you have an email address that includes a school. And if you do that, then you can download things for free. And their browser is called Sea Lion. Let me show that to you real quick. Where is right here? I'll open up. Yeah, I had it. Took a minute to come up. I'll go out to jetbrains.com. These guys are based out of the Netherlands. I think they are. They have offices all over the world now. They've gotten really popular. And I like JetBrains a great deal. If I was just going to do C and C++, I would probably just stick with Visual Studio. But I really like these guys for other types of IDEs. So if we look at their IDEs, I'm going to go to Developer Tools here. It's taking a minute for it to load up. I'll accept all. Let's go to Developer Tools. There we go. This guy right here, it's called Sea Lion, is useful for writing C and C++ code. And I like PyCharm a great deal. PyCharm is used for Python. And they've got some others here as well. So I just wanted you to know about JetBrains. If you go out to Education and you go for students and teachers here, you can get free licenses to the majority of these IDEs. I think Visual Studio Code is great, and you can write Python code, C code, C++ code. I'm sure you can write other kinds of code with it because Microsoft supports a variety of different programming languages. But also, if you're interested in something that's non-Microsoft, you might consider JetBrains. And if I'm being honest with you, I don't know if I can download CLion for Linux or not. Let's just do a quick little tour here. Go to CLion, see if it's available for Linux. And if I download this, what happens? Yeah, it looks to me, oh no, it is available for Linux, and it noticed here that I'm running on Linux. So you can get it for Windows, Mac, or Linux. So CLion would be something you might want to mess around with as well. Okay, now this movie went a little long. I just wanted to explain to you how this code is working. What I would recommend that you do now is that you go through, I will post this text for this particular little document that I created to show you how this thing works. I'll post the text as just text inside the video notes so that you can go through and validate for yourself how this is working. And I do recommend that as we get into things that are a little more difficult here, maybe we'll do a little bit more challenging C code. We probably need a full-fledged IDE to do the coding in this case. So that's all I've got for this particular movie. Thank you for listening to it. Thank you for watching it. Thank you for subscribing. Thank you for commenting. Please tell your friends about it. I'm trying to grow the channel. It is growing. Yay. I love you for that. Thank you so much for that. And I will talk to you in the next movie. Have a great, great day.